Okay, this is my first try at using this app to record a video. So I'm going to do example 7 here from chapter 12. I'm going to read that out first. It says, in a certain population of caribou, the probability of an animal being sickly is 0.4. If a caribou is sickly, the probability wolves eat it is 0.3. If a caribou is not sickly, the probability wolves eat it is 0.2. If a caribou is chosen at random from the herd, answer the following questions. Create a tree diagram before answering the questions below. So the term tree diagram here is referring to a diagram that looks like a set of tree branch, basically. And the reason that we try to establish that from this particular problem is that we can see, if we read a little bit more carefully, that these second two sentences, like if a caribou is sickly, the probability wolves eat it is 0.3. That's a given statement. It says the probability of wolves eating it, given it's sick, is 0.3. So first we have to know whether or not the animal was sick or not sick, and that's how I note not sick, okay? Hopefully the sub helped you understand that. And then the second event that we note is whether the caribou was eaten or not eaten. So the animal can be sick and then eaten, or sick and then not eaten. But we have to be careful because the same animal could be not sick and then eaten, or not sick and then not eaten. So we want to create this tree diagram where we have these 4 possibilities at the end of each one of the branches. And the deal here is that when we get to the very end of each of these branches, what we see happening is that the probability here at the end of this branch is that it's the probability the animal is sick and eaten. And then this one is going to be the probability that the animal was sick and not eaten, right? And then we keep going. So like this one's going to be the probability that they were not sick and eaten. And then finally, not sick and not eaten. Okay, so that's what we're going to end up finding in the very end. But let's fill in the values that were given in this paragraph. In a certain population of caribou, the probability that an animal is sick is 0.4. So that would go on this branch because that branch represents the animal being sick. Now, the second branch represents the animal not being sick. So if the possibility is the animal is sick or not sick, then we want to represent this as the complement. So to find this value and the opposite value on any branch, we'll take 1 and we're going to subtract the probability the animal is sick. So this one ends up being 0.6. Okay, and this is a 0 up here. It kind of looks wrong. This pen is hard to use, guys. All right, I'm going to try my best. There we go. Okay. Whew. So now we move on. The next sentence says, if a caribou is sickly, the probability wolves eat it is 0.3. So it's sick and then eaten. So that's 0.3. That goes here, okay? And we would repeat this similar math that we did to find the not sick branch down on the first level. We repeat on the second level. So we see that the caribou is sick and not eaten with a probability of 0.7, right? For being not eaten given it was sick. So we keep reading. If a caribou is not sick, the probability wolves eat it is 0.2. So I'm on my second branch. If the probability wolves eat it, that means I'm at 0.2. So I still take away from 1 to find my opposite branch here. So I want to find out the probability that the caribou is not eaten given it was not sick, which means I take 1 and subtract 0.2, giving me 0.8. So I want to emphasize here that each set of branches, each pair of values on each branch sums to 1. Okay, that's very important because each one of these sets of events is disjoint, which I know is something that we also talked about. And to find the probability of each one of these and statements at the end of each branch, we actually multiply the two probabilities from the previous branches together. So if this is sick and eaten, then I take the probability the caribou was sick, which was 0.4, and I multiply it by the probability it was eaten, which is given it was sick, which is 0.3. And if we do that, we end up with 0.12. All right? I'm going to keep going. So this is sick and not eaten. So we're going to take 0.4, but not eaten, that probability we see on that branch was actually 0.7. And if we multiply these two numbers, we get 0.28. Now I'm going to go ahead down the line and try these next two. Okay, so the next one we start with our not sick. So I want us to emphasize here that we're changing to the 0.6 because now I'm on the not sick bottom branch. But I'm going to multiply this one by the probability it was eaten. So that's 0.6 times 0.2, which gives me 0.12. And I'm going to go down that route one more time. So we've got 0.6 again because it was not sick. But this time we multiply by the probability that it was not eaten given it was not sick. And here we have a much higher probability of 0.48. And if you check, all of these are also disjoint events and they sum to 1. So if I'm just trying to check that I did my work correctly, I can always verify that these 4 values also sum to 1. If they don't, I actually made a mistake somewhere previously in my tree diagram. So the beauty of the tree diagram is that one of these 4 numbers we just calculated is probably the answer to question A or B. I just want to let you know that the formatting of this is crazy on the iPad. And the pages look weird and the letters are all really big. So I apologize for that. But the first question I'll read to you is, what is the probability of the caribou being sickly and not eaten by wolves? So it's sick and, right, which is my ampersand above, not eaten. So we're looking for sick along with not eaten. So the probability that it was sick and not eaten, we want to scan down our line, our table above. We actually wrote that exact same thing on line number 2. The probability there was 0.28. Now, the next statement here is a given, which is a conditional statement, okay? So the given probability, if you remember, the formula looks like this. The probability of A given B is equal to the probability of A and B, so they're now both happening, right? But B happened first, so we divide by the probability of B. So what we want to do here is the probability of, remember, we want to be careful, given the caribou was not eaten by wolves. So that's a weird way of writing this. They say given first. So the given it was not eaten by wolves, what is the probability it was sickly? So then we put that first because this is red. The probability that it was sickly given, this line literally means given, it was not eaten. So let's put this formula into context. The numerator is, this was an animal that was sick and not eaten. And then we divide by the probability that the animal was not eaten. So the numerator is 0.28. That's the probability we found for part A. The denominator, however, has to talk about all the ways a caribou could not be eaten. So the first way is that it was sick and not eaten, like we said before. But because these are all disjoint, we can add them together. The next way for the caribou to not be eaten, right, is somewhere up here in our chart. So our tree diagram, this was the first one we found. And in the very last line, right, you can see that we also have another way caribou can be not eaten. So we need to fill that in our denominator as well. And then we keep moving. So we do like 28. And then we divide this by point, I believe this is 76. Okay. And I do not remember the answer. I do not remember the answer, so we're going to put it in our calculator and we're going to get the answer. And you put that answer right here, okay? Round of 4 decimal places. We can check our solutions online.